Okay, so I would just like to do yet some more examples with the Turing machines, because you probably figured by now these can be quite difficult, and we've done several with this marking strategy, and I want to do some more with the marking strategy, and that'll probably do us for the rest of today, and then we'll move on to something a little bit different next time. By the way, we'll be back on our usual homework schedule. I already posted the assignment that's due on Tuesday, so check it out. Let's try a Turing machine. This is a little warm-up, so this one will be fairly similar to ones we did last time, although it's a little more complicated. A to the n, b to the n, c to the n. Oh, see you later. He don't like it. But the rest of us are going to do it. A to the n, b to the n, c to the n. We have actually mentioned this language once before. Anybody remember something interesting about this particular language? I don't know if anybody recalls, but A to the n, b to the n, c to the n. If you remember, yeah?
Context-free.
Yeah, this is an example of a language which is not context-free, meaning you cannot make a stack machine for this language. And you also can't make a context-free grammar for this language. You can make a grammar, but it must involve some weird grammar steps where the left side of the arrow is a more complicated thing. That's what context-free means. So remember, this is non-context-free. So in that sense, this is a much more complicated language than, say, A to the n, B to the n, which is context-free and has a very simple grammar. This one is not context-free. But actually, from the point of view of Turing machines, this is non-context-free, but I'll just say, no big deal. Like, it doesn't really make much of a difference. As a Turing machine, our answer for this is going to be pretty similar to the A to the n, B to the n. The fact that there's also C's in there is really not any kind of extra challenge to do this with a Turing machine. But anyway, our basic sort of structure of this Turing machine is going to look like, it'll be similar to A to the n, B to the n. And I hope you remember the strategy for this one. The strategy for A to the n, B to the n was, you start off at the beginning and you find an A and you mark it. That is to say, you change, the way we usually write this is, you change A to an A bar. And then you move to the right many times perhaps until you find a B, and then you mark that B, change it to a B bar. And then you go all back to the beginning and you repeat the process. All right? I hope you can imagine you can still do more or less the same thing. It's just you're going to mark an A, move to the right until you find a B, then mark the B, and then continue to the right until you find a C, and also mark the C, and then go all the way back to the beginning. So it's a very similar structure, and it will also sort of the large-scale shape of this thing looks like something like this with a big loop, and then some special. That's not meant to be an accepting state. I just mean you start somewhere, you do sort of a big loop here, and then you have sort of a end game little spur, if you will, at the bottom. Right? This is very much the same shape as the A to the n, B to the n machine. And our strategy this time will be mark A, then move to the right, then mark B, and then continue to move to the right until you find and mark C. And then you go back to the beginning. And then do the whole process over and over again. This is the general strategy for how the machine is going to work. All right, I hope this is enough sort of preamble. Let's see if we can actually get this thing going. So we will have a starting state, of course. And I'm going to immediately start my little loop here with an arrow that says A bar, R. That means when you begin, it better be an A to start with, because these strings, they must begin with A. And then you should mark it, move to the right. All right, I'm going to have a looped edge on this thing to represent keep on going to the right. Anybody have a suggestion? How could I express that? Really, I want to say something like keep on going to the right until you see a B. Although you have to kind of, you have to talk about which are the ones that I'm moving through. What do you think? AAR. AAR, she says. I like that. This means continue going to the right through all the other A's. You mark off the first A. You have to continue going through the right, to the right, through all the other A's. Until eventually you find a B. And then you actually, when you find a B, you actually do something different. So this is going to say B something something. Actually, there's another thing I need on the loop. You got an idea?
Go through marked B's.
Yes, I'm also going to say B bar R. This is because in later steps, later iterations through the big loop, as you're moving to the right in this step, you may encounter some B's that you've already marked, and you want to keep going past them also. Yeah.
Would you also go through marked C's, or is that later?
Do we need to also go through marked C's? I think in this step, you're not going to see any marked C's. This represents moving to the right in between the A and the next B. And there's not supposed to be any C's in there. If there was a C in there, the string should be rejected. So actually, if there is a C, I want for the thing to stop.
Okay.
Yep. Great. What about this B then? B. I said B slash. Anybody? Can you complete the? Like when you actually see a B, the question is, do I leave it as a B or change it to something else perhaps? What do you think?
B bar.
B bar. Yeah, you should mark it at this point. If you see the B, you should mark it. And then do I want to continue to the right or to the left? I'm going to move to the right, if you remember my little strategy that I wrote up here, right? You mark off the B and then move to the right. All right, we are now going to move to the right over and over again until you find the C. So I'm going to put another one of them loopy things here, representing I continue to the right. What are the labels that I need on this loop? Someone else? Yeah.
BB to the right, and then C bar to the right.
BBR, he says, like that, and C bar R. Great, yeah. At this point, between the B's and the C's, I have to move past some B's, and also I may have to move past some previously marked C's. Excellent. Okay. Eventually, after all of this moving over and over again, we expect to encounter a C, which we should mark, turn into a C bar. So I'm going to do like this, C bar. And at this point, I think we can begin to go to the left. So I'll put an L here. All right. We are going to move to the left continually. And you just have to think, what might I want to move through in this step? Could somebody else tell us? What do you think? Don't give me the silence right when the grandmas walk by. That was a tour involving grandmas, I think. Or just interested grandmas. Or perhaps childless old people. I don't know. What do you think? As I'm moving to the left, what am I have to go through? Somebody else? What do you say?
Move through all the C's, marked C's, B's, and marked B's.
Mm-hmm. So marked C's, marked B's, and B's. Yeah, I think so. Right? Do we also need the unmarked C's? I think actually at this point it's not possible to encounter an unmarked C, because we came up from the left side, marked off the first C, and now we're immediately moving back to the left. Yeah, but you may see marked B's or unmarked B's. And then eventually you will go back to the left. Now we have something that's a bit of a conundrum here is, let's imagine we went through once, for instance. This is just an example, right? Let's say we're like pointing right here, having just marked off this C. Now I want to go back to the left. Really, my destination is here, right? I want to end up there because I want to go back to the left until I get to the first unmarked A. What do you think?
Should you go through A's too, and then once you see a marked A, you go right?
Yes, I would say as we're moving to the left, you should also move through all of the unmarked A's until you hit the A bar. That's the signal that you have arrived, and you should move back to the right by one position. So I'm going to add to this loop here, AAL, and then my arrow that gets me back to the beginning, meaning, okay, do all of that again, should say A bar, R. That is, you move all the way back until you hit the first A bar, move to the right one position, and now you are in sort of your home spot where you're going to now repeat the entire process again. All right, excellent. I think this is the main, sort of the main loop of this Turing machine. I hope everybody feels good about this. This is the kind of thing which is very complicated, and in my opinion, you have to think this through very slowly. If you're doing these on the homework and you ask your friend, hey, how'd you do that one? And they're like, oh, it's just like this, and they show it to you. You're not going to say, oh, yeah, right. You have to actually tell your other friends to be quiet while you think very carefully about all these little arrows. Unfortunately, that's the way it goes. All right, but this is not the whole answer. This is just the main loop. Now we also need the sort of end game. So you should now decide. I'm going to make a little guide going down here, and I hope you don't mind. I'm going to have to scroll away some of that stuff. What's the signal that you actually are done? So you have to imagine yourself going through this whole procedure several times, moving to the right and back to the left. You end up back at the beginning. What are you looking at if you're actually done when you're back at the beginning? Any thoughts? It involves going back and forth here. You could, so this one, if we continued all the steps here, of course, at the end, it looks like this. The question is, where does the head actually end up after you run through this the last time? Yeah?
Is it B bar?
Yeah, I think the head ends up right here, all right? Because by the time you do this step, which moves you all the way to the left until you see the rightmost A bar, and then you move one more position to the right. So the head, in the final step, in the final time through this loop, if everything went well, the head should be looking at a B bar. And this is your signal to be done. So I say B bar here, B bar, R. Now that does not necessarily mean that the string is accepted, because we have to do one last check, and this is usually how these examples go. I'm going to run through the string one more time just to make sure that everything actually got marked. We need to make sure there are no extra B's or extra C's in the rest of the string that didn't get marked off yet. So I am going to move to the right through the whole string, and I think I can accomplish that just by doing B bar, R. This says go all the way to the right through B bars and also through C bars. But I did not put an ordinary B or ordinary C. So if there are any unmarked B's or C's left over at this point, then the machine will get stuck and the string will be rejected, which is what we want. If we eventually make it all the way to the end, we see blank, and that is our true signal that the string is acceptable. So it's like that to finish. These are complicated examples, in my opinion. There's some amount of similarity between the different examples, though. What do you think?
Does it ever go through A to check whether they're all marked?
This is a good question. What about checking if all the A's have been marked? I would say when you're doing this big loop, if you actually get back and there's an A that's not marked yet, it'll just go through the loop again. So that handles the A's. I think if you actually made it all the way through here, it's guaranteed that all the A's are marked. Yeah. Unless there's something very weird like an extra A at the end, possibly that would be unmarked, but you would catch that here. You would never make it to a blank at the end. All right. This is A to then, B to then, C to then, non-context free. But it turns out actually like Turing machines really have no problem with non-context free. The fact that it's context free or not doesn't significantly change the way that we handle it in a Turing machine. All right, All right. We got, what, 45 minutes? And I have 4 more examples. Do you think we can do it in 45 minutes? Maybe. These are not, I don't want it to seem like we're just doing the same thing over and over again. There are slight variations and different kinds of ways of thinking that we need to handle from time to time. So here is a slightly fancier one. I would like a Turing machine for a to the n, b to the m, c to the n plus m. All right. This one is context-free, actually, but it's not easier. It actually, for a Turing machine, in my opinion, this is a little bit harder than the one we just did. Here's my strategy for this one. So really what we have is a bunch of A's followed by a bunch of B's, and then some C's, and the amount of C's there are is equal to the total amount of A's and B's. That's how you should interpret these exponents. So something like a string like AA, BBB, and then CCCCC, right? There are 5 C's there because there were 3 and 2 of A's and B's. To me it seems like we should be able to do some kind of a marking type strategy, and this is really how you should approach all of these types of examples. I would suggest, my general strategy would be mark A at the beginning, and then go to the right. Now, in this case, actually, I would not say you should mark a A and then mark a B and then mark a C, because I don't actually want the same amount of A, B's, and C's, right? We want, it's different. It's kind of like you have 1 C for every A or B over here, right? So I'm going to say you mark A, skip over the B's, move to the right, and then mark a C. So that every A gets matched with a C. And then once I'm done with the A's, I do the same but with the B's, right? So mark the A, move to the right, mark the C, etc., right? Then you go back and do the next A. And then when the A's are done, I'm going to do the same with the B's, all right? Once you've marked off all the A's and sort of marked the C's to match, then there will be C's left over, but then I go back and mark the B's and mark the C's to match with the B's. And then at the end, hopefully everything will be marked. That's the idea, all right? I don't know if this sounds similar to you, but actually the large-scale structure of this at this point is actually 2 separate loops. There's this one here, mark the A, move to the right, mark the C, then go all the way back to the beginning, and do that over and over again. That's one little loop. And when you're done with that, then you go and do the similar thing for the B's. So the shape of this thing is something like you start somewhere, you do 1 loop here, and then when you're done with that, you do another loop like this. And then you have some kind of ending thing to eventually make it to the accepting state. All right? These can be a little tricky to just look at the example that you're given and decide for yourself how exactly is my strategy going to work out here. But I think this is the most sensible way to do it. All right. So let's just try and make this happen with the first loop, the second loop, and the ending. Maybe I'm going to try to. Often I draw my machines as sort of kind of vertically, but that's not very nice for the scrolling. So I'm gonna start here and do my first. I'm going to situate it kind of like this, right? That's how this is the general shape, the Easter bunny shape. That's the tail, right? And those are the ears. That looks like an Easter bunny, right? Okay, so let's start here as my starting state. It's perfect. I hadn't planned on drawing this picture, can you tell? This is not a rehearsed. I do have colors. All right, so from the first one, it's going to be marking A's and C's and skipping over B's. I think I can actually, so I did do this ahead of time. I can do this in 3 states. Marking A's, skipping over the B's, and marking the C's. Let's see if you agree. So my first arrow should mark a A. So I'm going to go A bar, R, right? And then from the next step, we have to move to the right continually. This will go through the B's, like I said, because I'm not trying to handle the B's at this point. I'm going to have to move my artwork. How about this? I'm going to keep it there. Like and subscribe if you see this on YouTube. All right, like that, moving to the right through the B's. I think we also need to move through some previously marked C's. This is similar to other examples. Maybe I'll just write down a typical string. When it comes to doing the A's, a typical string looks something like this. You mark this A, and then you go through here till you get to the C bar. Sorry, I should have put A's there also. A-A-R, right? After marking the first A, I have to move past some other A's. I have to move past some unmarked B's, and I also maybe have to move past some unmarked C's from previous steps. I eventually arrive at a C, which I mark. So this I go C, C bar, and here I might as well do L, right? Once you mark the C, you're going to start going back to the left. And then I should go all the way back to the left, so there's going to be a little loop here, which will say A, not A. What am I moving through as I go to the left? I may move through C bars, C bar, L. I may move through B's, BBL. And I may move through unmarked A's, like the other unmarked A's before I get to the first one, so that's an AAL. Eventually I get to a marked A, I go A bar, R, and then back to the beginning. That last R there will move me to the right one position, and I'll be pointing at the first unmarked A. And then I will repeat the entire procedure. All right, so that's my first little loop. Now we have to think, what's the sort of, we are going to go around this several times. From here now, what is the signal that we're done with the A's? This whole loop here is for processing the A's. What's our sign at this point that we're done with the A's? The head will be looking at, what do you think? Yeah, our head at this point will be looking at the first unmarked B once we've dealt with all the A's. All right, we will come back to the first A bar, move to the right by one position, but if this A actually is marked, if we're actually finished with all the A's, this A bar, R will lead us to this B. And so the B is our transition into the next of these loops. So I'm going to put another loop over here, which will look similar, but it involves marking the B's and then going over to the C's. And so the transition from one loop to the next is when I see B, we should mark it, B bar, and move to the right. And here's a little sort of trick. I don't know, this is not really a trick. Maybe a subtlety. This one actually should lead to that state. Because my general structure here is going to be, you mark a B first. So this loop I'm going to write as B bar, R here. Just like before, A bar, R. But it's just that when you come over here, you have just marked the first B. So you should kind of join in after the first step, because I just did the first step on this little edge here. Anyway, we do similar things here now. So mark the first B. I have to move to the right then through other B's, BBR. I have to move through some C bars in order to get to the first unmarked C. But eventually I get to a C that's not marked. I go C, C bar, R. Sorry, this should be an L. I mark a C, start going back to the left. I need to go back to the left through other marked C's and also through some unmarked B's. And then finally, when I get to a B bar, I go once more to the right, and then I'm back home. So these labels are basically the same as these, just with B's instead of A's And there are a little less complicated because you don't have to go through, in this first loop I had to go through these b's in the middle, which doesn't apply in this one. All right. It's complicated. Okay, anyway, this loop will eventually end here, and the signal that you're really done is you have marked off all the rest of the b's, and so you will see in this state you'll be pointing at a C bar, and that means you're done. So from this state, my sort of end game here is a C bar in that state. And now, as usual, I'm going to go through the remainder of the string and just make sure that it consists only of C bars. That's what should happen here, right? If we've actually done this whole thing properly, the rest of the string should be all C bars. So it's going to be a loop here, C bar, R. And if we make it all the way to the end, we accept. So it's like so. All right. How do grandmas like that? This looks like total nonsense if you're just walking by. Yes?
I made my B loop circle back to the starting state.
Back to here.
Yeah, so I had left there, then I went one right, and then instead of the third state you have, I just went back to the starting state.
Yes, okay. This is I think, if I understand correctly, so your two loops kind of look like this,
Yeah.
right? And then from here you do the ending.
Yeah.
More of a bow tie shape than a Easter bunny shape. Yeah, this is a very good idea for a simplification. I think it is not correct though, and here's why. If you arrange your string in this way, your diagram in this way, it allows you, for instance, to do the A part for a while, and then you do the B part for a while, but then you could start doing the A part again for a while. You should be concerned, for instance, about a string like A, B, 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 C, 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 A, B, 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 or, yeah, how about this? So here, this is two valid strings, one after another. If this is allowed to tie back here, I mean, it depends on the details of exactly how you drew it, but this is my concern, and this is why, to me, at least this is more obviously correct, because it's not possible to do any funny business like that. But this, you'll find, when you're doing the homework problems or something, you may get a different answer from your friend, and you will say, "Isn't that the same?" And your friend will say, "I don't know." It's hard to tell if these two approaches are equivalent. All right, great. Okay, let's try. So that was one strategy where sometimes you have to do a loop and then another loop. So this you can think of this as some kind of it's vaguely similar to like a concatenation sort of a trick where you're doing one thing first, and then when you're done with that, you go over here and you do this other thing. Alongside that approach, there are some examples where you want to do kind of two parallel branches, which is not this. This is more like one thing first, and then after that you pump it through another thing. But sometimes you want some kind of a two parallel branching. So let's try one with branching. And it's a matter of like intuition and seeing a bunch of examples to decide for yourself which of these strategies will be appropriate. Let's try this language. How about x in AB star, where x is equal to x reversed. So this is like a palindrome type string. I mean something like A, B, B, A, B, B, A, like that. The string reads the same forwards and backwards, all right? We are, again, going to do some kind of a marking strategy here. Does anybody see how you could look at a string like this and sort of mark off the letters one at a time to verify that it is actually the same forwards and backwards? I'll give you a hint. It's not like you mark a A and then you mark a B. You want to do something. I mean, you should start by marking this A. What should you mark off to match with it? Yeah, the A at the end. So basically you want to mark, but in this kind of arrangement, right? You mark this A to match that A. This B matches that B, etc. So you mark sort of front and back kind of thing, right? This is the idea. To be a little more specific about this, I'm going to say we mark the first letter. Then go to the end. Well, really, not necessarily all the way to the end, right? At least the first time it is all the way to the end. But really what we want is we go to the last unmarked letter. And then mark it. I would say parenthetically, if it matches, right? That is to say, if I started with an A, you go to the end and mark the A at the end if it actually is an A. If it's a B, you want to just stop and reject the string. But so we go to the last unmarked letter, mark it if it matches. And this actually is the interesting thing about this example, which hasn't come up in previous examples, is this kind of like if it matches. You have to mark this A, go to the end, and you're looking for an A. So if the first thing was an A, when you go to the end, you're looking for another A. But if the first thing was a B, when you go to the end, you're looking for another B. And so actually, depending on what the first thing is, you have slightly different behavior as far as what you're going to do when you get to the end. And so the general structure of this machine is like this. A bar R, B bar R. Because the behavior of the machine is different depending on if the first thing you look at is an A. If the first thing you look at is an A, then you're going to go to the end and look for another A. But if the first thing you look at is a B, you're going to go to the end and look for another B. So you have to put these in kind of two parallel branches. And the parallel branches are going to do basically the same thing, but they're just slightly different depending on whether it was an A or a B. So this is the general strategy for this one. Let's just try and draw the top branch. I'm going to give you a little spoiler alert just so you can organize your paper. The two branches eventually come back together because, of course, after you mark the first one and then you mark the last one, after that you don't have to remember anymore was it an A or a B. So after that they're going to do the same thing. So these are two parallel branches. You do have to do something different, but only kind of temporarily, and then they end up doing the same procedure overall. So this is the general shape of the diagram here. I'm going to give myself a little more room. Of course, there's going to be like looped edges here, so maybe give yourself some space. Anyway, let's try and do the upper branch, and the lower branch will be very similar. It's just with B's instead of A's, basically. So on the upper branch, the strategy you should have in mind, I'll just draw an example again. A, B, A, B, A, B, A. So this A is supposed to match with that A, right? You mark off the A at the beginning, and then I move to the right. You have to think, I'm moving to the right through some other letters. What should they be? Yeah?
Unmarked A and B.
Yeah, just A's and B's are what the other letters are going to look like. So unmarked A's, I'll go AAR, BBR. All right. Yeah, and when you get to the end, it's a blank. Or if you're thinking about in a future step, what's on the end might already look something like that, right? When I say go all the way to the end, really I mean you go all the way until you see one of the marked ones, and then you back it up by one, right? Or if you see a blank, that means you really went all the way to the end, but that's okay too. So here I'm going to say, if you get all the way to a marked one, you back it up by one. So I'll say A bar, L. But the marked one at the end, it might not be an A bar, it might be a B bar, so I have to put that also. B bar, L. And in fact, the first time through, it might be a blank. So I'm also going to put the big B, BL. All right. So this means I mark the first A, I run all the way to the end, back it up by 1, and now I should be looking at the last unmarked letter. And if it's an A, I should mark that one also. So that's what this last arrow is going to be, A bar. And then I guess I'll start moving back to the left. And this is the point at which the two branches meet, because at this point I will have started with one A and then matched it up with another A. And going similar things down this edge, I will have started with a B and matched up with another B. And after that's done, then the two branches can do the same thing. All right. So let's try to draw the bottom. The bottom branch should be basically the same. I marked the first B. Actually, I think this one should be entirely the same. If what I mark off first was a B, I'm still going to move through all the remaining A's and B's. So this here should go AAR, BBR. I'm still looking to get to the end now. The end either means a marked letter or a blank. So this labels in the middle will be the same also. A bar L, B bar L, and blank blank L. The only difference really is this last arrow. It's now going to say B bar L. That is matching off a B at the end to match with the B that I had at the beginning. All right. All right. So this here, either way you did it, this represents marking the first letter, going to the end, and marking that letter. All right. In order to, now I want to say basically just keep on doing that forever, but we have to somehow move the head all the way back to the beginning. So I am going to put a loop here, which moves the head to the left through all of the unmarked stuff. AAL, BBL. All right. If everything's going correctly, we should have the marked ones on the two ends of the string, and the head is moving back and forth in the middle. So as it moves back to the left through unmarked letters, eventually it gets to a marked letter, it should move to the right one more position and then go back to the beginning. So I conveniently left a little alleyway in the middle. Isn't this cute? If you have space through the middle, it should say A bar R, B bar R. Or you can make that arrow go all the way around the outside if you must. So this is my big loop. Any questions, thoughts about this? This, in my opinion, is kind of tricky, but it is a basic structure that you can copy in other examples. All right, let's just talk about the end then. How do we know when we're finished? I just erased that example. I probably shouldn't have. How do you know when you're finished? Like, what will this thing actually look like at the end? So, all of these guys will be marked. And actually, if you watch me doing this, they get marked off in this order, right? The one at the beginning, the one at the end. So after marking the last one here, this was a B in this example, so I will have gone here. Then it's going to do this, which actually won't go anywhere because there is no unmarked anything. It is now pointing. So in this case, this is the middle of the string, right? If this is a string with two pieces. Oh. This B bar L change that to a B bar and then move left here. This loop won't do anything because it's not unmarked. And so this edge here, sorry, I left out, there should be an R there. This edge here will push it back to the right by one spot. So I think at the end, what you find yourself looking at in this state, you will be looking at a marked letter. It might be an A or it might be a B, but this is your signal that you are done, that you've made it sort of to the middle of the string. In this state, if you see a marked letter. And I think actually it's just because of the way we set this up, there's no need to check more. Usually we have to go through the whole string and make sure everything is marked, but I think it's not necessary in this case because the whole strategy is sort of from the outside in. Once you end up in the middle here, it's not possible that there's anything that you missed. So from here, I think you can just go A bar, R to accepting, or B bar, like so. All right. This, I would say, is my final answer. Yes?
Is it the same ending if you have like an odd number of letters in the string?
This is a good question. Actually, I was going to say, there's one more thing. If the string, the ending looks slightly differently if the string has an odd number of letters, she said, right? This is a string which is sort of palindromic because it has two halves, and the middle is like a line through the middle. But there could be a string, just a much simpler example would be something like, well, I'm going to leave that there. Something like, ABA, right? In this case, what it would look like after doing all your business would be this. You mark off the first A and then the last A. And in this case, we have a B sitting alone in the middle. This, though, should also be acceptable. So how do we make this be accepted, right? If you mark the first A and then the last A, then you'll go, so that means you will have gone through this part of the loop. And you'll end up looking at this B. This loop will push you back one spot, so you'll be looking at A bar, and then you go through here. So you'll be back at this state, but looking at the B. So you will be in this state, but looking at an unmarked B. What will happen then is actually this will try to go down here. It will mark the B in the middle. All right. So this actually, the machine will just proceed from here. It will mark this B in the middle. Then what? Then this, so now it marks here. Now it's pointed at A bar. This does nothing. It goes A bar, L. So now it's pointed back here at B bar. It's looking at B bar right here. This should be accepted if you see a bar right now. So this is the somewhat weird extra kind of end game for this example. If you see a A bar or a B bar here, it should be accepted. This happens if there's an extra letter in the middle. That's the only way that you could encounter a bar at this point right here. It means you marked off a letter, moved to the left, and immediately you saw another marked letter. All right? And this extra thing here needs to be copied in the top branch also. This is now my really, truly final answer. Quite complicated little alien. All right. I have one for you all to try. We got 15 minutes left over. I think this will probably do it for us. I would like to try let's try a Turing machine for strings on A's and B's. Of course, X and AB star, where the number of A's equals the number of B's. All right? This is going to have a very similar shape to the one that we just did. So it again is going to look sort of like this. Because the strategy, the number of A's equals the number of B's. I'm talking about something like A, B, A, B, B, A, B, right? The idea is you should mark an A, and then you want to cancel it by marking a B. The number of A's and the number of B's has to be the same. So you want to mark an A and then match it up by marking a B, and then go mark another A, match it by marking another B, etc. So it's very similar to the one that we just did, only you have two branches based on whether the first letter was an A or a B. If you see a B first, then you should find a A to mark with it. See what you think. gets so hot in here. I just wrote a sequence of how I would mark these letters off one at a time, maybe for inspiration if you're not sure. Actually make to the end before we find the dimensions that should be rejected. And so you don't leave without the machine.
You just marked today.
Should work, I guess. Yeah, pretty good. The left, so after marking, so you mark the first letter, then go find a match and mark that. I think you want to sneeze back to the left, perhaps many steps to the left. Like you should basically go back to the beginning. You should have one left and then another right. Then somewhere there has to be a loop to the left. Goes back. think it's not necessary to do that. In this case, the string will be accepted and the head will end up.
Well, I'm just thinking because if you go bar once, you're gonna end up right here.
Yes.
But that's okay.
Yeah, the head doesn't need to be on the end when you finish.
No, it just needs to be like.
You just have to make sure that the whole string is marked up. But because of this, and usually on the other ones, you want to go all the way to the end to make sure there's no extra letters on it. But here there couldn't be extra letters on the end because we weren't.
But just because they're all marked, that makes the end. Okay, gotcha. Thank you.
How's it going?
We want this, like, I think that's the A part.
So we're going back to the beginning.
That's good. So I would say these two arrows actually can, like those two states can actually be.
Oh,
Because
okay.
after this step, you hand that, and it's no longer necessary.
Right. Yeah.
All right.
I don't think it's right, but
It's pretty good. So you want this?
Maybe we want these.
Somehow this is not necessary. I think these can go. Here it's like you go. I would suggest actually this. A gets marked, and you're gonna look for a B to mark. So you don't, I don't think you want B.
okay.
Like this loop should only go through other A's, which are most, or B bars. Which are looking for a mark. All right.
Oh, there's a.
Alright, so, okay, you mark this A, and now at this point you're looking for a B to mark. I like this arrow. I can't think you don't necessarily know these things. You want to stay in this state, and look like there should be a loop here, which continues to move to the right until you see a unmarked B, which gives you this arrow. Let's see what you can do with that. I'll give you 2 more minutes and then we can talk about it. Same as the previous one. Yeah. I think this, don't mix fingers. When I did it, I only had it. So this says
Yeah, I read that before you.
Yeah. Getting there. I know that little.
Yeah, it's on this side.
You start with A's and you count the first B, you go back to the beginning.
Can we talk about this? Sorry, I didn't get around to everybody, but we gotta go soon. There are different strategies. As I was walking around, I learned that some people liked to go all the way to the end of the string to match up. This wasn't my intention though. So my intention was, for example, if you look at this sequence of markings, I mark this A, and then I start to move to the right looking for a B to mark. And I found this one, and I marked that B. I'm not gonna try to go to the end and mark the last B, just because I don't think there's any reason to do that. You might as well just mark the next B that you see. So the way you can, if you want to, go all the way to the end, although I think this is an unnecessary sort of complication to things. So I would say A bar R, and then here I'm going to continue moving to the right until I see a B, unmarked B. That means I need to perhaps pass through some A bars, also perhaps pass through some B bars, and also perhaps pass through some A's, right? These are all the things which I am not looking for. You have to kind of like list out everything that you want to skip over. What I am looking for is B, and once I find B, I should mark it.
Why would you need to go through A bars? Because I thought you were looking at A's from left to right, so would there not be A bars?
That is possibly true. Yeah, I don't think it's wrong to put it there. Maybe you don't need it. I think you don't need it. Yeah, I'm not entirely convinced. I'm gonna leave it in there, but yeah. Okay, so eventually we will find a B bar, which I want to mark. Now the way I did this, I was able to do this entire sort of loop thing with only 4 states. So I say B bar, and then L. And I found it easiest to write this machine to just go all the way back to the beginning of the string. So here I'm going to go all the way back. AAL, BBL, A bar L, B bar L. No matter what we've done so far, I just marked off 1A and 1B, and then I go all the way back to the beginning. And similarly, the other branch has to basically look the same, but the other way around. So this arrow here will say A bar L, and the loop on this guy will have, this is B bar, so I'm looking for A's at this point, so I'm going to go through other B's and B bars. Sorry, this should say B bar, B bar R, and AAR. No, A bar R. I'm looking for an A, so I move through everything else. All right. Now, after marking off, I have the way that I set it up is this thing is going to move all the way to the left to the very beginning. It will see a blank, and that's my sort of pitch back to the beginning. Blank R. All right. This is the basic shape of it. And as usual, I have a little end game thing. Yes?
If you go all the way to the left and then once you reach a blank, you go right, wouldn't you just like go back to the first A that was then marked?
Yes. So there's one extra little thing that I'm going to put here, which is, like he said, the idea, let's imagine you go through the top branch here. The first letter is an A, I mark it. Then I search for a B, I mark that somewhere. Then I go all the way back to the beginning. I come back here. But then the second time through here, then I will be starting at the first A that I already marked. So it'll be looking at an A bar. I want to just move past anything that has been marked. So my little trick to make that happen is this. A bar R, B bar R. So this. Now if you wrote your machine so that it didn't go all the way back to the beginning, then this might not be necessary. But because I went all the way back to the beginning, I will have to push myself through some ones that I already marked at the very beginning before you even start this loop again. All right. Anyway, what happens at the end? We got 1 minute. What happens when this is all done? If they're actually all marked, it will end up, looking like this. Here's an example of one where everything is marked. If you went through the last thing to mark off, I don't know what it would be in this example. I suppose it would be this B would be the last one that gets marked. Then you go all the way to the beginning. You start up the loop again, you do this thing, it will automatically push you all the way to the end. So if you see in this state a blank, that means that you've actually made it all the way to the end through this whole thing. And so this should be like this, blank, R or whatever, accepted. All right, this is how I did it. So it's about time to go. These are quite difficult, and really you need to play around with them for a bit. So check out the homework. You will get some playtime on the homework.